Welcome back to the deep dive. Today we are grabbing a machete, metaphorically speaking, and hacking our way through the jungle of high-res video distribution.
Yeah, it can feel like a jungle sometimes.
Absolutely. If you've ever been in a huge casino, maybe a big corporate center or, the world's biggest sports bar, and just wondered how they get dozens of 4K feeds to dozens of screens.
Without that spaghetti monster wiring nightmare behind the scenes.
Exactly. Then this deep dive is definitely for you.
Our focus today is really simplifying that whole equation. We're getting into the technical details and the features of these WolfPack 4K 30 hertz AV over IP matrix switchers.
Right.
The idea is to give you the blueprint, the key technical bits, the commercial side too, for systems that can handle, say, up to 40 TVs using pretty standard network gear.
And that's the real shift, isn't it? We're moving away from those older, proprietary, often expensive fixed matrix boxes.
Those big, heavy things and dedicated racks.
Yeah, needing special cables. Now we're talking about running high-quality audio and video, AV over standard IP, Internet protocol, using the network cables maybe already in the walls.
Precisely. And the source material flags two really crucial technical points right away for this WolfPack system. One, it supports 4K resolution, specifically at 30 hertz.
Okay.
And two, it uses PoE technology.
PoE. So for anyone maybe prepping for a meeting, let's quickly pin that down. PoE, power over Ethernet. What does that actually do for an installation like this? Why is it such a big deal logistically?
Oh, it's huge. Logistically and financially, PoE means you don't need an electrical outlet right there at every single TV or display.
Oh.
You run one network cable, a Cat-T6 cable usually, to the receiver unit behind the screen, and that single cable. It handles both the data, the 4K video signal, and the power for the receiver itself.
Wow, okay. So that dramatically cuts down on installation hassle.
Massively. Fewer electricians needed, less wiring complexity, lower overall cost. It's a real game changer for deployments.
Okay, let's unpack the architecture then.
Yes.
Because that's where you really see the shift from the old way to this new flexibility. The source gives an example.
Yeah.
A 14 input by 32 output system, 4K, 30 hertz HDMI over IP PoE matrix switcher.
Right, and look how streamlined the components are for that scale. You've got your 14 PoE HDMI transmitters, the TX units. They take the signal from your source, like a cable box, a PC, whatever.
Okay.
Then you have 32 PoE HDMI receivers, the RX units. Those sit behind the TVs.
Got it.
And all that traffic, the video routing and the power, it's all managed by just one 48-port PoE Ethernet switch, a standard network switch, essentially.
Now here's the part I found really clever, and it must solve a major headache for integrators managing inventory. The source says the transmitters and receivers, they're actually the same physical box.
Exactly. Yeah. It's all defined by software. You install the unit, and then you use the software to tell it, okay, you're an input TX or you're an output RF.
Brilliant.
It's huge for, supply chain, for training, for stocking. Think about it. You've basically cut your potential ordering mistakes in half. You only need to stock one type of box, one SKU.
No more managing two separate part numbers, hoping you ordered the right mix. That flexibility must really play into scalability too, right?
Absolutely. Because it's all built on standard IP networking, the claims the system makes, like unlimited sources, unlimited computers, USB and KVM, unlimited HDMI ins and outs, they're actually achievable.
So unlimited isn't strictly true, but it means you're limited by the network switch size, not some fixed chassis.
Precisely. You're limited by the number of ports on your standard Ethernet switch, which you can easily expand. It's not like an old matrix where if you bought a 16 by 16, that's all you ever had. Here, it's dynamic. Any in to any out, any way you want.
Okay, so we've ditched the proprietary stuff. We're using standard CT6 network cable. How far can you actually run the signal with that common cabling?
That's another impressive spec. Even using that widely available, relatively inexpensive CT6, the system reliably extends the signal up to 450 feet.
450 feet, that's a pretty long run for a stable 4K video.
It's a very significant distance, yeah. It covers most large rooms, halls, even connections between floors in many cases.
Okay, big question then. Bandwidth. We're sending 4K video, which is data heavy, over standard network infrastructure, often just 1 gigabit per second switches. How does it, fit? How's the video compressed?
Right, this is key to making the whole thing work cost effectively. The system uses the H.265 compression protocol.
H.265, okay, why is that important?
Well, H.265 is really efficient. It's what allows that high-resolution 4K stream to run smoothly over a standard 1 gig Ethernet switch. If it used an older compression or maybe none at all, you'd need much beefier, more expensive 10G switches everywhere.
I see. So H.265 is kind of the magic ingredient that makes this financially practical on standard network hardware.
Pretty much, yeah. It keeps the infrastructure costs down significantly.
And what about the legal side? Content protection, security compliance, things corporations need.
Covered. The system's confirmed as HDCP compliant. That's high bandwidth digital content protection. Absolutely essential for playing commercial content. You know, from DirecTV, Blu-ray, streaming boxes. They won't play on non-HDCP systems.
Right. The screen just goes blank.
Exactly. And it also mentions SEC security compliance, which points towards meeting those higher-level enterprise security needs.
Okay, let's talk performance, because this is always the acid test for AV over IP.
Yeah.
When you compress, send over a network, decompress, there's always some delay, some latency. The source quotes 80 milliseconds for switching and latency. How should we think about that number? Is 80 mils good?
80 milliseconds, so less than a tenth of a second, is actually very snappy for an encoded 4K IP system like this.
Okay.
For things like digital signage, corporate presentations, even folks watching in a bar or lobby, it's pretty much unnoticeable. It's certainly fast enough for the 4K 30 hertz live streaming capability they mentioned too. Adds a lot of utility.
But, playing devil's advocate, for an integrator setting this up, what could go wrong on the network side? What could make that latency worse, maybe even noticeable? You said network management is key.
Yeah, that's where issues can creep in if you're not careful. Poor network setup is the usual culprit. Things like not segmenting the network properly or having unmanaged multicast video traffic flooding the switch.
So if you just plug it into the main office network with everything else running on it?
That could be trouble. This system really expects a well-configured, ideally dedicated 1 gig PoE switch for the AV traffic. If you let tons of other data clog that switch or don't manage the video streams correctly, you'll introduce jitter, lag. That 80 meters figure assumes a properly managed network.
Got it. So network hygiene is crucial. Okay, speaking of management, the control side sounds pretty straightforward. Not some super technical interface.
No, not at all. It seems designed for the venue manager or the end user, not necessarily the deep network engineer. Control is via tablet. They mention iOS and Android apps or a PC.
And they specifically call out an iPad real-time video preview of all sources.
Yeah, I like that feature too.
It sounds incredibly useful. So the manager can literally see little live thumbnails of every input
Right on their iPad.
before they switch it. That avoids sending the wrong football game to the big screen, right?
Exactly. Takes out the guesswork, makes switching visual, intuitive. Just point and tap on the WiFi app. Really streamlines operations.
Okay, let's circle back to growth. A system for, say, 40 TVs is great now, but businesses expand. How does this handle future-proofing? What if they want 60 TVs next year?
That's the beauty of the IP approach. You don't throw anything away, you just add more standard network capacity. This system supports cascading multiple Ethernet switches together.
So you just plug another switch in?
Yep, plug in another switch, add more transceivers for the new inputs or outputs, and you extend the system's reach. They explicitly call it unlimited field upgradable.
And it's not just video, right? The KVM support seems like a big plus for corporate use.
Definitely. KVM keyboard, video, mouse control means someone at one desk can control multiple computers or servers located elsewhere, all routed through the same system over the network.
Handy.
Yeah, and beyond the main video streams, the specs mention separate audio outputs on the units, 3 USB ports for peripherals, and the whole core system is rack-mountable. Setup and detailed control use dedicated Windows software.
That scalability is vital. Okay, let's move from the rack gear to the really visual stuff. Video walls, these systems seem built for that.
They really are. The video wall capabilities sound quite seamless. Because it's IP-based, it treats all the connected screens like a single digital canvas.
You're not limited to just mirroring content.
Right. It supports any size video walls, could be a 2x2, a 5x3, whatever layout you need, and any quantity video walls within the network's capacity. The receiver units coordinate via software to stitch together one huge image across multiple screens.
That sounds way simpler than the old method. Didn't you used to need dedicated, expensive video wall processors just to handle the synchronization and aligning the images across bezels?
You often did, yeah. This integrates that logic, making those big, impressive architectural displays much more accessible, much less complex to set up.
Now, speaking of specialized uses, the source mentions an optional sports bar system. This seems like a perfect real-world example of that whole any in to any out flexibility.
Oh, yeah, let's paint the picture. Think about the manager of a busy sports bar on a game day. Maybe 40 screens, 15 different DirecTV boxes, some cable boxes, maybe a few Rokus.
Nightmare scenario.
Total chaos.
Right.
Trying to find the right remote for the right box while customers are yelling for their game.
And this optional system integrates control over all those different source devices.
That's the idea. It creates one unified control point. Using the iPad app, the manager can apparently change channels on DirecTV, DISH, cable boxes, even Rokus, right from that single interface.
Wow, okay. So one person, one iPad, can instantly send any channel to any TV across the whole venue.
That's the claim. And to make it even easier, the control interface can show a visual floor plan of the venue on the iPad.
Like a map.
Exactly. The manager taps the icon for a specific TV on the map, sees what's playing, and can instantly route a different source to it. Plus, it handles comprehensive audio control too, making sure the sound follows the video in different zones. It's designed as a complete operational control solution.
That really does sound like a seamless experience, especially for those high-pressure venue environments.
Mm.
Okay, let's pivot to the practical side. Money and logistics. What should someone expect budget-wise for this kind of system?
Understanding the cost structure is pretty straightforward because of that combined transmitter-receiver unit, the transceiver.
Right, the single box.
Individual transceivers start at $250 each, according to the source.
Okay, so that gives a clear baseline cost per endpoint. If you need, say, 10 inputs and 30 outputs, that's 40 transceivers times $250, plus the cost of the network switch.
Exactly. It makes estimating pretty transparent. And for context on bigger systems, they list a 10 by 40 system, so 10 inputs, 40 outputs, at $14,725, and a 6 by 40 system at $12,325.
Considering you're getting 40 controllable 4K outputs over standard IP infrastructure, those prices seem quite competitive for a pro-level system.
They do, especially compared to traditional matrix solutions of that scale.
And there's another financial point that really jumped out at me, especially for businesses. It explicitly says no monthly license fees.
Yeah, that's huge.
Yeah.
Absolutely massive in the world of specialized AV control software. A lot of competing high-end systems hit you with recurring license fees, often per endpoint or per year.
So eliminating those recurring fees is a big deal for long-term budgeting.
Absolutely. Once you buy the hardware and the initial software, your core operating cost for the switching system itself becomes fixed. That predictability is golden for businesses planning budgets years out. It removes a major ongoing expense.
Good point. And it speaks to stability. The company behind it, HDTV Supply, seems established too.
Yeah, the source mentions they've been around 24 years, certified since way back in 2003. And the brand names, WolfPack and WolfPad, are their registered trademarks. So it's not some brand new player.
Okay, so let's boil this down. For you, the listener, maybe thinking about a large AV project, what's the key takeaway here? These WolfPack systems seem to tackle that big challenge of distributing lots of high-res video by using standard IP networking.
Right. They blend that 4K 30 hertz video quality with the scalability and, importantly, the lower cost of standard gear like TT6 cable and Ethernet switches.
The main value seems to be flexibility and affordability for complex needs.
I'd say so, yeah. You get robust, low-latency video on common infrastructure, plus that really important benefit of no recurring license fees for the core system.
It's kind of a blueprint for getting a lot of screens running without needing a fortune in specialized hardware or ongoing software costs.
Exactly. Now, to leave you with a final thought to chew on, we talked about how the transmitter and receiver are the same physical box, just defined by software.
Right.
And the system is described as unlimited field upgradable. So here's the question. If the core function is already software defined, what could that flexibility mean for future-proofing? Could we see maybe a future firmware update allowing the existing hardware to handle, say, a new, more efficient 8K compression standard? Could this system potentially evolve beyond its current 4K 30 hertz spec just through software without needing any new boxes?
Interesting. So the software-defined nature might make it adaptable in ways traditional hardware can't be.
It's something to consider when you think about the long-term value and adaptability of your network infrastructure investment.